Hello, everyone. We are presenting our brainstorm video on sleep disorder detection. Our aim is to develop a model that predicts whether someone may have a sleep disorder focusing on the two primary types, insomnia and sleep apnea. Sleep disorders impact the ability to get restful quality sleep, and they can significantly affect uh, an individual's daily life. And while there are various types, each disorder generally has its unique causes, risk factors, and treatment options. So, our goal is to build a model that can detect sleep disorders based on a person's sleep patterns and lifestyle factors. Specifically, we're trying to classify if an individual has normal sleep, insomnia, or sleep apnea. Insomnia, it's the difficulty falling or staying asleep. And it can be acute or chronic, with both significantly impacting the daily life. Sleep apnea is a condition that causes repeated interruptions in breathing during sleep, and it often leads to poor sleep quality and is associated with symptoms like loud snoring and gasping for air. And from our data set, some lifestyle factors that may contribute to these disorders, which include stress level, occupation, and physical activity level.
Next, we're going to talk about some proposed data science methods that we could apply to our problem. Some of these include exploratory data analysis, data preprocessing, and model implementation. To start us off, we'll talk about exploratory data analysis, which can help us uncover patterns, detect anomalies, and test hypotheses within the data, providing insights that guide further analysis and model development. For this project in specific, one of the most important patterns that we can look at is the correlation between the variables in the data set. We can do this specifically by creating a heat map of our data to see what characteristics can help us predict if someone has a sleep disorder. And at the bottom right here, we can see an example of what that heat map looks like with highly correlated variables versus low correlated variables. Next is data preprocessing, which cleans and transforms raw data, improving data quality and making it suitable for analysis. Some benefits of this include accurate models, faster training, reducing overfitting, and consistent results. In our case, the biggest preprocessing we have to do is to transform any categorical values into numerical values so that they can be fed into the model and then processed. This step is called label encoding. At the bottom right, again, we can see an example of what this is. So we can see that on the left, that's the data in categorical values, which is red, green, blue. And then we transform those into numerical values of 0, 1, and 2 so that our model can read it. Lastly is model implementation, which is the last step of choosing the model that best fits our issue. And so, since we want to predict sleep disorder presence, this is inherently a classification problem. However, since we want to classify normal sleep, sleep apnea, and insomnia, we have three target variables. So, this is a multi class classification problem. For this, we can use a random forest classifier model, which, as we can see to the right, decides between three different classes and then votes on a final class.
Our model will be able to identify key risk factors such as stress level that contributes to these disorders. Additionally, our model's predictive capabilities allow it to assess if an individual outside of our data set, based on their own data, may have a sleep disorder or not. And some practical applications of this model include an early screening tool that flags at-risk individuals and support remote monitoring, which allows healthcare providers to track patients' sleep health over time. And it can also be integrated into the Sleep Health app where users receive personalized insights and actionable recommendations to improve sleep quality. Thank you.